Welcome to this session in which we will learn to estimate a confusion matrix in R that will help us to compare the precision between models. Well, we are here in R, and the first thing that we are going to do is to predict the probabilities of the logistic regression model that we computed in the last session. So we will create the variable prediction2 because we are going to predict the probabilities of the model 2, which equals to the function predict. And the first parameter will be the name of the model, model 2. The second parameter will be the dataset that we want to use to predict, that will be testing. And finally, the type of prediction, that in this case will be the response, not a probability. And I will press enter. Now let's see your prediction. View prediction 2. And as you can see here, we have a vector with probabilities. It is not a vector with zeros and one. We have the probabilities, and now we will set the cutoff threshold on 0.5, and we will do the classification, and that's what we are going to do now. Now let's classify the observations of the dependent variable defaulter flag based on the probabilities of prediction 2. First, we will create a vector of 5,781 ones, the size of the testing data frame. So we are going to create a vector with the same size of this testing dataset. You can see here the 20% of the total observations. So let's create this vector of 1. We will call this variable classification model 2, which equals to rep of repetition of the number 1 5,781 times. I press enter, and now we have this classification model 2. You can see it's practically a vector with 5,781 ones, and now we will assign zeros to those observations with a probability less than 0.5. That's our cutoff point. So we are going to again call the same variable classification model 2, which is now formed of only ones, and we will select those observations which have a prediction probability or a predicted probability in our vector prediction 2 less than 0.5. So those that are less than 0.5, we will assign a 0 to the vector that at this time is only formed by ones. And now you can see, we can view this. We will view classification model. Here it is. Now you can see a vectors of 1 and zeros. The prediction was probabilities, and now we have classified based on this prediction. We have classified on zeros and 1. So the ones are the observations that we think, or that the prediction that the model predicted that had a probability of more than 0.5 of being default. Now let's convert classification model 2 to a factor, and we're going to do this because the function that we will use to create the confusion matrix requires that the data, that both set of data have to be factors with the same number of levels, in our specific case 2 levels 0 and 1. So we are going to convert classification 2 to a factor. Classification model 2 equals the function as factor and the same number, the same name, the same variable, classification model 2. Press enter. And now you can see that classification model 2 is a factor with 2 levels. And finally, we're going to construct our confusion matrix, the confusion matrix of the classification that we just did. And for this, we will use the function confusion matrix that it's in the package E1071. So we will have to install a package, install.packages E1071. I have already installed this package, so I'm not going to press enter, but if you haven't installed it, in fact, you have to correct this. If you haven't installed it, you have to install it. I'm going to put it on the library, E1071. Rstudio is suggesting me the package. And once that we have put E1071, we are going to use the function confusion matrix, which is part of this package. Confusion matrix. Actually, we need this in order to run the confusion matrix. But as you can see, it was part of the correct package. So we are going to write confusion matrix, and there are 3 arguments. The first of them will be the classification model, comma, and the first will be the classification that we did of the model 2 with what we have done in this session. The second will be the actual data, the real data, the one that was in our testing dataset. So we're going to convert it as factor, testing, the sign of $, and then the name of the dependent variable, that is the filter flag. Then we are going to press comma, and we are going to indicate to R that the positive observations are the one that had a 1. So with this, it could do the confusion matrix. We press enter. Some seconds, we have computed the confusion matrix. You can see over here the predicted and the actual data. So we can see that there are 458 values that were 0 and were predicted as 0, as false. Well, we also can see that there were 3,778 observations that were true and were actually predicted as true. And we can see the errors here, the 337 and 1,208 observations that were not predicted as the real observation. So you can see that the logistic regression model has an accuracy of 0.7327, so around 73% of accuracy. In the next session, we will do this for our neural network model. Thanks for watching.